There are 3 sub-questions for this question. We need to add the following numbers and express each result in engineering notation. So let's begin with the first question. Here, we're going to work on the solutions together. Question A, let's copy down the expression. 2.5 times 10 to the power negative 3 plus 5.6 times 10 to the power negative 3. So first thing, let's check the exponent. The exponent of that power of 10 for both numbers. For the first number, exponent equal to negative 3. The exponent for the second number is also negative 3. Since both numbers have same exponent, that power of 10, they all have negative 3. That means we can simply add two numbers directly. So the 10 to the power negative 3 occurs in both terms. We can simply factor out this common factor. The 10 to the power negative 3 is the common factor. So we need to factor out this common factor. First, equals to, put a big parenthesis, and then copy down that common factor. Multiply 10 to the power negative 3. And then put the corresponding terms in the parentheses. 2.5, we put this in the parentheses. The operation is addition, so we put the plus inside, and then put 5.6. So we can simply add those numbers inside that parentheses. 2.5 plus 5.6 equals to 8.1, and then just copy down that base of 10 term times 10 to the power negative 3. So let's check if this number is in engineering notation. The number before the decimal point is 8, which is between 1 and 1,000. So this number meets the first requirement of engineering notation. And then let's check the exponent. The exponent equals to negative 3. It is a multiple of 3. It meets the second requirement of engineering notation. Therefore, this number is in engineering notation. This is the answer for question A. Now let's move to question B. First, copy down that question. 74 times 10 to the power 6 plus 43 times 10 to the power 6. If you check the base of 10 portion of both terms, they all have same exponent that equals to 6. That means we can add the numbers directly. Otherwise, we have to do some adjustment, so both numbers have same exponent. So first, that equals to a, let's put a big parenthesis, multiply the common factor, 10 to the power 6, and then put the 74 inside the parenthesis. The operation is addition, so put a plus here, and then add the second number, 43. 74 plus 43 equals to 117, and then just copy and paste the remaining term. Multiply 10 to the power 6. The final check is to make sure this number is in engineering notation. 117 is between 1 and 1,000, so this part is good. The second part is that exponent equals to 6. 6 is a multiple of 3 because 6 equals to 2 times 3, right? And integer 2 multiplied 3 equals to 6. So it is a multiple of 3. Therefore, this number is in engineering notation. No need to do extra steps for adjustment. It's already in engineering notation. Question C. First, copy down that expression 1.24 times 10 to the power 6 plus 384 times 10 to the power 3. Let's check the exponent. For the first number, the exponent equals to 6, and then equals to 3 for the second number. Two exponents are different. Since they are different, we need to do some adjustment. We need to align the numbers, so they need to be the same number. We can either change the first exponent, that 6 to 3, or we can change the second one, that 3 to 6. So I just arbitrarily chose the first number. I changed that 6 to 3. Change here to 3, we need to move the decimal point. So the number need to be same. Since we reduce the exponent from 6 to 3, the second portion of the number, the base of 10 portion, is decreased. The number part need to be increased by same amount. So we need to move the decimal point to the right 3 times. Once, twice, and 3 times. The decimal point is here. This number is 1240 times 10 to the power 3. Now that base 10 portions are same, they are all 10 to the power 3. Now we factor out this common factor, which is 10 to the power 3, put a big parenthesis, and then put the first number inside, which is 1240. Operation is addition, put a plus sign here, and then add it to the second number, 384. 1240 plus 384 is 1624. And then just copy the remaining, that base of 10 term, 10 to the power 3. Now let's do a check. Make sure this number is in engineering notation. The first portion is 1624. It is greater than 1,000, right? It's outside the range. It's supposed to be between 1 to 1,000, but this number is greater than that. It's outside the range. Therefore, it's not in engineering notation. We should reduce this number. So the number before the decimal point is between 1 to 1,000. Move the decimal point to the left 3 times. Three times, right? Shrink the number by moving the decimal point 3 times. We need to do some adjustment for the base of 10 term, so the value retain the same. Also 3 times, but increase 3 times to the exponent 3. Become 6. Let's check the number now. 1.624. 1 is the number before the decimal point. It is between 1 and 1,000. For the exponent, it is 6. 6 is multiple of 3. Therefore, this number is in engineering notation.